Hello, hello everyone. We are the students of electrical department. Here our topic for this FCS feedback control system subject is the modeling and simulation of active vehicle suspension system. And here my group members are Omkar Ayer, roll number 1, Swapnil Anap, roll number 2, Prasad Bansode, roll number 3, and myself Chetan Monkar, roll number 3. Here our project guide is Dr. Vijay Kumar sir, and subject is the feedback control system. Uh, here we have here we have replaced the suspension system, spring with a spring and damper with the accumulator. So we are getting the best output, and here because of best output and a good quality of output, and so introduction. The transmission of road generated vibrates to a vehicle body is treated as a source of a path and a receiver problem, and the suspension system acts as a path of a transmitting force and motion from the body vehicles the way and vice versa. The spring and damper are the passive components of a suspension system which acts as a shock absorber and energy dissipators and respectively, thereby the putting the limitations on the transmission, those the forces and the motion. However, suspension and preferences can generate it improved by the using active suspension system adaptive feedback control technique. Here the source is of our problem is a vehicle body and treated as a source of path, and where the suspension acts as a transmitting force, and where the we can say the feedback control where the using active suspension system. This paper route present the design of a feedback controller called as a notch filter for active suspension system. Root locus approach is used for design tool in active suspension system. Sensors are used to measure the accelerations. Sensors are measured to use acceleration and sprung mass and unsprung mass and the analog signals from the sensors are sent to the controller. The controller are designed to take a necessary action to improve the performance and abilities already set. The controller amplifies the signal which are fed to actuator. The generator the required forces to form a closed loop system. Active suspension system. The performance of the system is then compared with that of the open loop system. Passive suspension system, a quarter vehicle suspension model with a 2 degree of a freedom system consisting of one sprung mass and one unsprung mass. Considered as a for the simplicity, then analysis of a MATLAB Simulink is used to simulate the characteristics of a vehicle suspension, effect of a vibration of a design parameter such as a stiffness and damping constant of the performance suspension and turn, and in the turn of a ride characteristics of the vehicles also studied. And now the Simulink model of this project will be shown by the next member of my team, Prasad Bansode.
So next parameter is half car suspension. This is a rear suspension. So this is arrow is downside. The meaning is look inside the mask. So this is rear suspension denoted by K is equal to KR, C is equal to CR, L is equal to LR. Means rear. So we see that parameter. So this is a block parameter of rear suspension. So half car suspension, the spring and damping rates for an individual wheel are entered below. Their combined effect as applied of two wheels at the specific distance from the center of mass is computed. The distance should be specified as positive if the subsystem is oriented such as increasing z correspond to increasing the theta. The spring rate is Kr. We give the value 21,000. Damping rate means Cr. We give it at 2,000. Moment arm means Lr is equal to 1.2, and we can cancel it or apply it. And the same like from front suspension, stiffness is equal to spring rate Kf is equal to 28,000, damping rate Cf is equal to 2,500, moment arm is minus Lf minus 0.9. So we move it here. So half per suspension, the damping rates individual wheels are interval, means like same like rear suspension. Their combined effect is applied of two wheels at the specific distance, means the distance between front and rear is applied. So this is also our step response. We take it from simulation library. Time is 7 seconds, before is 0 second, after is 0.01 second. So we see their block parameters. So we move it here. Output step time is 7 seconds, initial value is 0, final value is 0.01, sample time is 0. So our another parameter is theta. Theta was the second order integrator IC source is denoted by 1 upon s square. So we look at the parameters. Second order integrator. Initial condition source x is equal to internal. We can select it external or internal. So we select internal. Okay. Initial condition is minus 8.7 in 100 plus 20. So here we can set limit x, brackets, absolute tolerance x, eto, state name x, and we can apply here or otherwise okay. So this is connected to this bus bar, or we can say MUX multiplexer. This is another one, and this is last bus creator 2, this is bus creator 3 1, and this is our initial, or we say start. So we see the parameters. So bus creator, number of inputs, 2 inputs are we take and send out one output. Element in the bus, theta dot, we can here refresh, up, down, add, remove, and we can require names of input to match above. This click on OK. This is a subsystem mask. So this open another window. So this is also our next model of sum. This shape is round. Add or subtract input. Specify one of the following character vector containing plus or minus each input. For place between, for example, plus plus, minus, plus plus. We click on OK. So this is our simulation modeling, which is shown in blocks. So for the result, we click on modeling. In this modeling, we say the run option, stop time at after 10. This is normal simulation mode. So we click on run. So this is a compiling. So here that show the compilation result.
Hello, in this topic we see how vehicle suspension system work and where we can use in basically we see the in a circuit diagram the various components are available just like a theta angles, forward suspension system, backward suspension system, rear suspension system, and a pitching moment. When before the conclude that topic we see we take one example just like we see a seesaw. When someone heavier are sitting the other sides it's automatically it's a down. It's similarly when happens with the vehicle, when vehicle accelerate to the forward side, it's automatically weight are all weights are comes to the backward side. And it's a we call it as a pitching moment. And next is a theta. Means theta means how many angles force are applied to the backward sides. And high means higher the theta means we are see the car how cars weights are it's the backward side. The next is the forward suspension system. When cars are move the forward sides, the all are pressures on the front end. I mean the front suspension system are complex and it's a shock. We using the spring or others backups. We are overcome that things. Next is a rear suspension system. How rear suspension system is work we are see when it's all weights are comes to the that's a back end side. At the end when we see the diagram see at the same time how rear system is work. At the same time suspensions comes to into the play. It's a help to the balance out the pitching motion extended in like when rear system is work. At the same time suspensions comes to into the play. It's a help to the balance out the pitching motion extended in like when
बंटी भाई पाय आता 1 2 3.
So this is our output of suspension model of active vehicle suspension. So firstly, we see the oil columns. That is, first column. First column is d theta by dt, and these are the measure the forces and moment of displacement. So firstly, first column you see the value of firstly value of x is 3.32 and the value of y is 0.08, and the difference between the value of firstly we get 2.62, and after the value of is 3.5, the value is increases in the output. So in second column we see the value is 3.45, and the value of and when the reaction of front vehicle is increases, the value of x is also increases. So the value of increases due to by the reaction of the force. Next, we see the height of the road. The value of height of road is x point 7.32 and 0.01, and the movement is increases, and the height of a road is also increases. So next will be we see the formula of d theta by dt. The value is in a radian per second. So we see the difference between our height. As we know, there are certain formula is applied due to. Next will be the all the values are given in this format. So you see the firstly in difference between the value of that given in each column. Firstly we see the value is increases, then value is increases due to acceleration, movement and displacement, and everything, and these are our output. We get the difference between the value of the vehicle suspension. This value will occur in our model, so we get the very much comfortable in vehicle.